All right, so I'm recording this. Notes, absolute value and absolute value equations. All right, absolute value is the absolute distance from that value to zero. So if I'm walking from here to Heber, I'm walking about 4 miles, right? But what if I walk from here to Heber backwards? How far am I walking? Still 4 miles, right? Because distance is always positive, right? So the keyword is distance right there on the definition. So we know that the absolute value is always going to be positive, right? Because there's no such thing as negative distance. So if you wanted to visually see on a number line, let's say here's 0, 1, 2, 3, negative 1, negative 2, negative 3. What would the absolute value of negative 3 be? 3, because you're here and it's 1, 2, 3. The distance is 3. How about the absolute value of positive 3? It's also 3 because it's the absolute distance from that value to 0. Let me show you. Here's 3. Let's go to 0. It's 1, 2, 3. So it doesn't matter which direction you're traveling in. It's still distance is positive. So the absolute value of negative 3 is 3. The absolute value of positive 3 is 3. Do we understand? All right. It's a bit more tricky though because we're so used to not having absolute values. Some of us would like to change this to a plus plus. That would be incorrect. Okay. We can do, and we should do, the absolute value of negative 3 first. What's the absolute value of negative 3? 3. So we have a 3 right here, no more absolute values, and the 5 and the negative are going to come down. 5 minus 3, and 5 minus 3 is 2. That's your answer for that question number 3. Number 4, this one's a little bit more interesting. It's kind of like going through PEMDAS again. Parentheses, there are no parentheses, but there are absolute values. So let's zoom into the absolute value. And what could I do there? 4 minus 6, what's 4 minus 6? Negative 2. So I really have a negative 2, and I still have the absolute values, and I might as well rewrite everything to not make a mistake. We have a 2 out here, a minus, a 5, and it's to the third power. Now I still have the absolute values, and I could do the absolute value of negative 2, so that's what we're going to do next. What's the absolute value of negative 2? 2. So I really have 2. I'm going to put parentheses around it, just to not get confused. I still have the third power on it. I still have the 2 in front of it, and the minus and the 5. So now I have 3 operations. I have subtraction, multiplication, and exponents. What do I do? Exponents, right? So what is 2 to the third? What's 2 times 2 times 2? 8. So I really have 8, and I'm going to keep the parentheses to not get confused and think that it's a 28. It's really a 2 times 8, right? So final step would be to multiply. 2 times 8 is 16. Bring down the minus sign, bring down the 5. 5 take away 16 is negative 11. Done. I hope we understand absolute values and how to simplify with absolute values. That probably will be one of the first questions on the quiz. Now we already know that a solution to an equation is the value that makes it a true statement, right? Like if I told you x plus 1 equals 5, what does this value have to be? 4. Why? Because 4 plus 1 is 5. There's no other number that you could plug in here that'll make it a true statement. So we know that the answer to an equation is the value that makes it true, right? So let's look at this easiest type of absolute value equation. It says the absolute value of x equals 3. What number would be an answer right here?
Negative
3 and negative 3, right? So it actually has 2 answers. So x could equal 3 and x could equal negative 3. So write down both answers right below it because that's technically your answers to this absolute value equation. Now, I want to have us observe what is the difference between this answer and this original equation. The absolute values are gone, right? And this was the positive situation. Okay? But there's also a negative situation. And the negative situation, it's the same exact thing as the positive situation, but all you do is change the sign of the right side of your equation. So this 3 became a negative 3 on the negative situation, right? Now, why am that's kind of ridiculous, but I'm explaining that because it'll make more sense, or the steps will make more sense after observing that. So here are the steps to solving any absolute value equation. Step 1 is to isolate. What does isolate mean?
Leave it alone.
Get it by itself, leave it alone, right? Get it by itself on one side of the equal sign, and in this case, on the left side. Step 1, isolate the absolute value on the left side. So let me ask you this. Is number 1 with an isolated absolute value? Yes. There is no times 5. There is no plus 7, right? How about over here? Is this absolute value isolated on the left side? No. There's definitely a 4 right here and a plus 5 right there. So we're going to have to, on the first one, we don't have to do step 1 because it's already done for us. It's already isolated. But let's go through and read the rest of the steps, that is. So if it's already isolated, we move on to step 2, and that's to create your two equations, the positive and negative situations. How? Well, the positive situation, we said it was exactly the way it is without the absolute values. That's how we're going to write the positive situation. And the negative situation is the same thing, but change the sign of the entire right side of the equation. All right? So let's go to number 1, and since it's already isolated, I could jump right into the positive and the negative situations. I'm going to put a squiggly line between the two. I recommend that you guys do this, especially right now that you're refreshing your minds on algebra right here. Set it up exactly like this, positive and negative. Now in the instructions it says a positive situation is writing it exactly the way it is without the absolute values. There it is, nice simple equation, no absolute values. The negative situation is the same exact thing, but you have to change the entire right side of the equation. Change the sign of the entire right side of the equation. So that 2 is going to become a negative 2. And those are your two situations, the two equations that you actually have to solve, right? So the positive situation equation, you'd have to get rid of that minus 13 by adding 13. And what you do to one side, you must do to the other side. So add 13 over here. Those 13s are gone. We end up with x equaling 15. That is, actually I shouldn't be confident and say that that's one answer. That could be an answer, all right? Sometimes both answers work. Sometimes only one works. Sometimes none of them work, which would mean no solution. Anyways, the negative situation, we're going to solve that by adding 13 as well. Adding 13, we end up with x equaling 11. So that's another answer. But if we go back up to the steps, we did step 2, we created the positive situation and the negative situation. Step 3 is solve, we already did that. But make sure you check your answers because you may have extraneous solutions. It's a fancy word right there, extraneous. What is an extraneous solution? It's simply an extra solution that doesn't work. Right? It's an extra answer that doesn't work. So down here with our two answers, there's still a need to check. If I plug in a 15 right here, 15 take away 13, that's 2. And then the absolute value of 2 really is 2. So this one works for sure. Plug in an 11 right there. 11 take away 13 is negative 2. And the absolute value of negative 2 is also 2. So both of them work. You have to write both answers down to get full credit. If you only write 15, you're only going to get half credit because you need 2 answers to be completely correct. Let's go to number 2 over here. So what's step 1? Isolated. Is this isolated?
No.
No. What do I need to do to start isolating that absolute value? Subtract 5. Perfect. All right, so subtract 5 here. And what you do to one side, you do to the other side. And you have 4, absolute value, 2y minus 7, absolute value equals 4. So we almost have the absolute value by itself. All we need to do is get rid of this multiplication of 4 that's out in front, right? So we're not going to distribute. These are not parentheses, right? These are absolute values. So we want to get rid of the 4. We want to isolate the absolute value. So how do I get rid of that multiplication of 4? Divide by 4. It's going to cancel out. What you do to one side, do the other side, divide by 4. And again, you're going to have to write pretty small right here. You have the absolute value of 2y minus 7, absolute value equals 1. Now that it's isolated, now we can move on to step 2, which is setting up your two situations, the positive situation and the negative situation. So the positive situation is writing it exactly the way it is without the absolute values. However, don't go back to the original one. That'd be bad. That'd be really bad. Go to this one right here that has the isolated absolute value. Okay? Rewrite this isolated absolute value equation without the absolute values, giving you a 2y minus 7 equals 1. And for the negative situation, same thing, 2y minus 7, but you only change the sign of the right side, making it a negative 1 instead of a positive 1. Then of course we're going to solve both. The left one, add 7, you'll end up with 2y equaling 8. Divide by 2, you get y equals 4. Let's do the other one. Plus 7. We're going to have 2y equaling 6. And we're going to divide by 2. And we have y equals 3. And again, we need to test these two solutions to make sure that there are no extra answers, right? That 4, if you plug it into the isolated one, you could do it to the original, but I recommend the isolated. It's easier. Plug in 4 right there. 2 times 4 is 8. 8 take away 7 is 1. The absolute value of 1 really is 1. Plug in 3. 2 times 3 is 6. 6 take away 7 is negative 1. The absolute value of negative 1 is positive 1 as well. So both of them work. You have to write down both of these guys to get full credit on your answer. Number 3, what do I do?
Isolate.
And what would that consist of?
Divide.
Dividing by negative 3. So I get absolute value of 4x minus 9, close absolute value, equals what? Negative 8. Okay, now what do I do from there? You know what I realized? We didn't complete the notes before moving on to these questions. Check this out, guys. Let's go back up here. Very important. If you ever isolate an absolute value and it's equal to a negative number, you can conclude no solution because there's no such thing as negative distance, right? We know that you can't do, like, what's the absolute value of negative 5? It's 5. What's the absolute value of positive 5? It's also 5. There's no way that you could do the absolute value of something and get a negative answer. So since down here we isolated it, we have the absolute value all by itself, you can't do the absolute value of something to give you the answer negative 8. It just can't happen. So right off the bat right there, you could just do this. You're done. That means no solution. You could write out the words no solution, or you could put that 0 with the line through it. Any questions on that? So those are super easy problems. All you got to do is remember that fact. Remember the fact that if you have the absolute value equals to a negative number, you could just stop doing what you're doing and just say no solution. There is no answer. Okay? Now, if this negative 8 were a negative 8x, then I'd have to keep going, all right? But it's not negative 8x, it's a negative 8. I know it can't happen, it's no solution. Let's keep going here. Number 4. By the way, all this stuff is from Algebra 1. All these absolute value equations are from Algebra 1. This is more starting to be like Algebra 2 right here, number 4. Why? Because there's variables on both sides. So again, you want to isolate the absolute value first, which it's already isolated. So what do I do next? You do the positive and negative situation, right? Now, what is the positive situation? If you forgot, you could read it on the instructions. It says rewrite it exactly the way it is without the absolute values. And the negative one is a little tricky. It's the same exact thing, 8 plus p equals, but you have to change the right side of the equal sign. You got to change that whole thing to a negative. Not to a negative, but change the sign of it. So before, where we just had one number over here, yeah, if it was 5, change it to a negative 5, right? If it were 7, change it to a negative 7. But right here we have a binomial. So we're going to have to change this binomial by multiplying that binomial by negative 1. In other words, you need to change the 2p to become a negative 2p. And you also need to change that negative 3 to become a positive 3. Does that make sense? Cool. Now we're going to solve both of these. On the left side, I want to get p by itself. So I'm going to subtract p right here and subtract p over there, giving me one single p on the right side. Let me rewrite everything. The minus 3 is there, the 8 comes down because the p is canceled. After that, I'm going to get rid of the minus 3 by doing plus 3, and I will have 11 equaling 1p. So the answer is p equals 11. On the other one, I'm going to add 2p and move it over this way, plus 2p, giving me a 3p, and the 8 comes down. That is a positive 3p, so I'm going to put a plus in front of it. I still have the equal sign. I still have a 3. I need to get rid of the 8, so I'm going to subtract 8. Subtract 8. And I'll get 3p equaling negative 5. Final step would be to divide by 3. So you have p equaling negative 5/3. Now, unfortunately, if you do all that correct work, all right, sorry about that. So once you get to these two answers, you're supposed to double check them, right? You're supposed to double check them. So if you plug in 11 right in here, 8 plus 11 is 19, and you plug in that same 11 over here, 2 times 11 is 22, take away 3 is also 19, so that's a true statement, so this does work. But when you plug in this negative 5/3, by the way, you could use a calculator to plug in fractions, but you could just use the fact that this is a negative fraction. It's a negative number. And if you plug in a negative number right here, it's going to be 2 times a negative number. That's a negative number. And then subtract 3, it's still going to be negative. And it's impossible to take the absolute value of something to give you a negative answer. Does that make sense? So this guy cannot be a real answer. That's what we call an extraneous solution. So I'm just going to put a line through it. So on your test or on your quiz, if I give you this problem, I expect to see the answer p equals 11. And please do not put the negative 5/3. Even though you did all that correct work, it's not a real answer. That's what we call an extraneous, you don't have to write it down, but solution. It's an extra answer, so we don't include that on our answers. Now, number 5 is the craziest one because we're dealing with fractions. I don't want you guys to be scared of fractions. Let's isolate first by dividing by 2. We have the absolute value of 4 minus n equaling negative 3/2 n. Now that we have the absolute value isolated, we'll do the positive situation, which is 4 minus n equaling negative 3/2 n. It's the same exact thing, but no absolute values. The negative situation is the same thing, 4 minus n equaling, but instead of a negative 3/2, it's going to be a positive 3/2 n. So let's solve both of these. Now this is where you could use decimals if you want, or you could use fractions. I'm going to explain it using fractions. I'm going to get rid of the minus n by adding n. And what I do to one side, I do to the other side. I'm going to be adding 1n to the negative 3/2 n. So whenever you have a fraction and you're trying to add or subtract something from it, it'd be good to have a common denominator. So what I want to do is I want to convert this 1 to become 2 over 2. 2 over 2. Because 2 over 2 is 1 anyway, right? And now that you have a common denominator, 2 up here and 2 down here, now you could deal with the numerators and just say negative 3 plus 2. What's negative 3 plus 2?
5.
Close?
Wait, oh.
Negative 1, right? Negative 3 plus 2 is negative 1. You owe 3, you have 2, you're going to owe 1. And of course, it is over the common denominator 2. And we are talking about n's here. So negative 3/2 plus 2/2, that's really a negative 1/2. And of course, the 4 comes down, the equals comes down, and you need to solve for n. How do you get rid of things? You do the opposite. So the opposite of dividing by 2 would be to multiply by 2. That would cancel out. But what you do to one side, you do to the other side, multiply by 2. So you're going to end up with 8 equaling negative 1n, which means that your final answer, n, is going to equal negative 8. What do you think? Good question, and that is the beauty of math. There's many roads to the same place. So you could get rid of the fraction from the beginning if you wanted to. You could multiply this by 2, making it a negative 3n, but you'd also have to multiply both of these by 2. So this would become an 8, this would become a negative 2n as well. As a matter of fact, let's try it on this one, yeah? Okay, let's try it on this one. Let's get rid of the fraction right from the start by multiplying every single item by 2. So if I put a times 2 right here, the 2 will cancel. If I multiply the n by 2, it'll become a 2n. If I multiply the 4 by 2, it'll become an 8. So I really have 8 minus 2n equaling 3n. Wow. I think it is way easier, huh? Thank you, Paulina. So let's continue solving by adding 2n to this side, adding 2n. We will have 8 equaling 5n. And the final step would be to get rid of this multiplication of 5 in front of the n by dividing by 5 and dividing by 5. So n equals 8/5. So there's one answer. There's the other answer. But we need to test both of them. So yeah, I think it's way easier to get rid of fractions right from the start instead of dealing with fractions. So take this negative 8 and plug it into the isolated one. You could do the original, but it's more math. So if you go to the isolated one, if you plug in a negative 8 right here, what's 4 take away a negative 8?
12, negative 12.
The minus negative becomes positive, right? So you have 12. 4 minus negative 8 really becomes 4 plus 8, which is 12. And the absolute value of 12 is 12. So over here, when you plug in that negative 8 over here, it'll also be 12. It takes some work though. Negative 3/2, plug in negative 8. It's pretty easy because negative 3 times negative 8, that's positive 24. And it's still over the 2 right here. So it's still over 2. So you also get 12. So we see that this does work. The n really does equal negative 8. Now on this one, when I plug in this positive 8/5, I don't even have to actually do that because when I plug in any positive number here multiplied by this negative number, it's going to give you a negative answer. A negative answer. And you already know that the absolute value of anything is not negative. So this one's extraneous. It doesn't work. Does that make sense? Once again, when I take this 8/5 and plug it in right in here, a negative times that positive 8/5 is going to be a negative, and we know it's impossible to take the absolute value of something and it be a negative answer. So we right off the bat, we don't have to do any work. We could just say, no, this one doesn't work. It's an extraneous solution. So the only answer, number 5, is n equals negative 8. So that concludes the notes for the absolute value equations. We're now going to work on a homework assignment on absolute value equations.